In this video, we'll take a look at the Heathkit SW-7800 General Coverage Shortwave receiver. Shortwave radios were a part of Heathkit's product line, starting with the AR-1 in 1949 and ending with this unit, the SW-7800, which was produced until 1990 as they were leaving the kit business. There were about 15 models of general coverage shortwave radios offered over the years, not counting those that were intended for amateur radio band reception only. The SW-7800 was introduced in 1984, selling for $349.95 and offered as a kit. It came after the model SW-717, which was sold from 1971 to 1982, after which there was a 2-year gap in which no shortwave receivers were in production by Heathkit. The SW-7800 is a synthesized shortwave receiver covering 150 kHz to 30 MHz with digital display. It runs on AC power or an external 11 to 15 volt DC power supply such as an automobile. It sports a 5-digit red 7-segment LED display with 1 kHz resolution. Operating modes are lower sideband, CW upper sideband, and AM wide and narrow. It has AGC automatic gain control with slow and fast settings. A local DX switch can reduce the gain, and a muting input is provided for use with a transmitter. It has a headphone output as well as a line level output to a tape recorder. It has a built-in telescoping antenna or can use an external 50 ohm or long wire antenna. It was sold only as a kit. After assembly, alignment only required a high impedance voltmeter. Sensitivity is rated at less than 0.35 microvolts on single sideband and CW and 2.5 microvolts for AM. Selectivity is 2.5 kHz in single sideband CW and AM narrow modes and 5.5 kHz on AM wide. Image rejection is 55 dB and it weighs 7 pounds or 3.3 kilograms. The unit's housed in a brown metal case with a plastic front. This brown was the color Heathkit used during this period, replacing the green they used over much of their history. Some images on the internet appear more blue or gray, but I don't believe it was offered in any other colors. It has a similar styling and case to the Heathkit HW9 QRP transceiver. There's a 5-digit red 7-segment LED display reading in megahertz with a resolution of 1 kHz. To the left of the frequency display is an analog S meter calibrated in standard S units from 0 to 9 and plus 20 and plus 60 dB. A 2-position AGC switch sets the speed of the automatic gain control circuit. Slow is best for CW and single sideband signals, and fast is typically used for AM, especially when experiencing fading. Phones is a 1/4-inch jack for low or high impedance headphones and disconnects the speaker when plugged in. Rec is a 1/8-inch jack with line level output for connecting to a tape recorder to record on-air signals. Unlike the headphone jack, the level is independent of the volume control. RF10 reduces the RF gain for strong signals. The band switch has 30 positions, one for each of the 1 MHz band ranges. Each 5th range is marked on the panel. Volume controls power and the audio level. The mode switch has 4 positions. LSB for lower sideband, which is commonly used by amateur radio below 10 MHz. USB CW for upper sideband, commonly used above 10 MHz, and CW or Morse code. Narrow AM for amplitude modulated signals with a narrow bandwidth, useful when there's interference from adjacent stations. And wide AM for amplitude modulated signals with a wider bandwidth for higher fidelity AM such as AM broadcast band stations. The large main tuning knob adjusts the frequency within the selected 1 MHz band. The bands overlap slightly by about 200 kHz. The display shows a resolution of 1 kHz, but unlike some modern radios, the tuning is continuous and not in discrete steps. It uses a vernier and pulley reduction system, providing about 35 turns of the knob over the full range. On the rear panel is the AC line cord hardwired in. There's a UHF SO239 connector for a 50 ohm antenna, typically coax cable to a dipole or inverted V. The high impedance terminal is for a long wire antenna. To use the internal telescoping antenna, you connect the short jumper wire to the high impedance terminal. The internal antenna extends to about 50 inches or 127 centimeters and has a loading coil in the center. It can easily be removed by turning and unscrewing it. The local DX switch can be set to local to attenuate the input against overload by strong local AM stations, or DX, which stands for distance, for maximum sensitivity. It's recommended to use the local position for signals below 2 MHz when using an external antenna. A ground terminal is also provided. The radio is not required to be grounded, but it's helpful especially with a long wire antenna. A phono jack marked mute is for use with a transmitter. During transmit, if the transmitter or a relay closes the circuit, the receiver will be muted. EXT power is for operating the unit from an 11 to 15 volt DC power source, such as a car battery. Let's turn the unit on.
So based upon those comments, guys, one quick note here.
The speaker is quite large and produces good sound and adequate volume.
You know, take what you can get before that. Fowler says, yeah, you know, he's been suspended by all.
The SW-7800 was known to drift when first powered up. I tend to see about 2 kHz maximum of drift in the displayed frequency from cold. After about 20 minutes, the drift is minimal.
Fowler seems to believe that Jacksonville lets him go in any way she will be sanitized, and I believe there's actually 3 stages of cleaning because we're all very conscientious about making sure that nobody touches any devices that could potentially make them ill.
The unit's an interesting hybrid with an analog tuning capacitor, but still synthesized and with a digital display. It would be nice if the tuning had resolution below 1 kHz, but this is not too bad, and it was a big advancement in accuracy over earlier analog dials. Note that it goes down to 150 kHz and covers the AM broadcast band. Here I'm listening to a local AM broadcast station. You can hear the difference in sound fidelity between AM wide and AM narrow.
We want to make sure that they're used, and we want to make sure that people are feeling connected. All of the patience that goes into working with seniors that may have not worked with technology before, tell us how you work with seniors.
You may be able to hear that, although the difference would be a lot more noticeable with music rather than speech. You can see the difference between fast and slow AGC settings by touching the antenna input with the whip antenna disconnected to make the signal stronger and then releasing it. The S meter shows how the AGC circuit recovers either quickly or slowly. So this is slow. And fast. For amateur radio, we can pick up CW, Morse code, and single sideband signals. Here's an example of a couple of CW signals on the 40-meter amateur radio band. And there's some radio teletype.
We're not, I'm not an original West Virginia. Nice to meet you, Joe.
Nice and cool there, and great to hear you out of Ohio. You have a good one there, K9, JRK, K8, New York.
Tuning single sideband signals is a little tricky but doable. And here's some shortwave broadcast stations on AM.
Onda corta.
I can demonstrate the mute function with a cable connected to the jack on the back. If I short the pins, the receiver goes into mute mode.
Road work is something that can be done with a lot less traffic on the streets these days. Perhaps we can take advantage of that opportunity. But other projects, for instance, the Cogswell and the changes that may be had to be postponed for a period. And we're looking at other projects which can reinvigorate the.
The unit came with this DC power cable so that it could be powered with an external power supply or from a car battery or a cigarette lighter. The top and bottom covers are easily removed with 4 screws to provide access. In terms of design, it's a dual conversion superhet with a first IF frequency of 50.455 MHz and second IF of 455 kHz. Bandwidth is determined by an active filter for the audio signal. It uses a beat frequency oscillator for single sideband and CW modes and a product detector. An AC power supply generates the DC voltages. When using DC power, it uses a DC to DC inverter to step the voltage up to the needed 15 volts DC. The synthesizer uses a voltage-controlled oscillator and phase-locked loop. One 28-pin 7216 IC handles all frequency counting and display driving. Taking a look inside, most of the circuitry is on printed circuit boards with some wiring to interconnect them, some of which uses ribbon cables. The top half has the synthesizer board and the controller board, which has a shielded compartment. You can see the front-mounted speaker, a small display PCB with the 7-segment LEDs, and a very small PCB for the band switch. Here's the tuning capacitor with vernier and dial cord. The S meter is illuminated with a pilot lamp. On the bottom half is the large receiver board. We can also see the power transformer and power supply circuit with fuse. There are small coaxial cables to the front panel controls. We can also again see the tuning capacitor and dial cord. The line voltage goes to the power switch. A line filter is there behind a metal shield for safety. I was fortunate that the unit came with a complete set of original manuals. These seem to be quite rare, and I cannot find any manuals or schematics online. As is typical for Heathkit, the manual is comprehensive with over 130 pages, plus a large illustration booklet and schematic. The manual had a number of errata pages with changes to make in the manual. There were enough changes to the synthesizer board that they provided an updated schematic for it. I've been looking for an SW-7800 for several years, but prices on eBay have gone through the roof even for parts units, and many sellers will not ship to Canada where I'm located. I eventually found one for sale privately from a local Ontario seller on the internet. It was in working condition with original manuals, antenna, and power cable. As you can see, it's in very good condition. I gave the unit a thorough inspection and some minor cleaning, and it seemed to be working fine. I went through the alignment procedure, which only needs a high impedance voltmeter. The procedure is relatively simple and straightforward. A few pots and coils need to be adjusted or peaked. The radio has a detector circuit built in for alignment purposes, and the final step is to zero beat its reference oscillator against radio station WWV at 10 MHz. You do need to unsolder one shield to perform part of the alignment. I noticed some intermittent noise during alignment, which I could duplicate by pushing on the PCBs. This went away when I tightened up the screws holding the PCBs to the chassis, so it was probably a grounding issue. This unit is very clean inside and no modifications were made to it. The name and address of what was presumably the original builder was penciled on the back of the manual. This was not the same person that I bought it from, so it's changed hands at least once. The SW-7800 was a decent general coverage shortwave receiver. It's lacking some of the bells and whistles of other receivers of the era, but was certainly adequate for shortwave listening and even for amateur radio for a beginner or as a backup radio. The cost of $349.95 in 1984 is equivalent to almost $900 today, so this was not an inexpensive radio. By comparison, the SW-717 from 1971 to 1981 sold for $59.95 to $119.95 over the period that it was offered. A big selling point of a Heathkit would have been the fun and bragging rights of building it yourself from a kit. Compared to other commercial shortwave radios of the same price range, it was criticized at the time for lack of features and for being drifty. Reports are that it did not sell particularly well. A number of modifications have been suggested. These include reducing noise by shielding the frequency counter ribbon cable and changing some resistors and capacitors for better audio response. Given that there were design changes made over the life of the radio, I'm not sure if all of the mods apply to all units. I didn't attempt to try any of these mods. It is interesting to see how much technology had changed just from the preceding SW-717 model to the SW-7800. The 7800 moved to a digital display and internally makes use of many more integrated circuits. While a digital display is great, there's still something to be said about an analog dial for visualizing where you are on the band. Over the last number of years, I've been trying to collect all of the Heathkit shortwave receivers. Apart from the AR1, which is very rare, and the AR2, which is almost identical to the AR3, which I have, I now have all of the non-amateur radio shortwave receivers that Heathkit made. Note that I've made some other YouTube videos on just about all of these receivers, so you may want to check them out as well.